Okay, now traveling waves. What does the word traveling mean? Going places? So these are waves that go places. So when a disturbance is created and it travels away, that's called a traveling wave. These are also called progressive waves. So when we were little, all of us throw rocks in the river, right? And you see the waves that come out of it? Those are called traveling waves. So the waves that travel are called progressive waves or traveling waves for short. How do you set up a traveling wave? So if you are this person holding on to this string, if you move the string up and down, it sets up a pulse that moves away from the person with a certain frequency F, which corresponds to how often I move it up and down, and a certain speed by which this wave will travel. Under an undamped condition, this pulse will go all the way down the pipe or the string or whatever you're holding. Okay? For our class, we are only going to consider undamped situations. We are not going to talk about dampening or anything like that because that makes it really complicated. Okay, so remember this. Moving it up and down sets up a wave with a certain frequency F with a speed V. And that's what it looks like. Okay, so this person is moving it up and down, and the wave is traveling forward. Now, it doesn't mean that it has to travel forever. So like, for example, when it hits this boundary, what will happen? It will reflect back. And then when it reflects back, it may set up a standing wave. If I pause my wave at any instant, there are certain things that will happen. One is frequency will be how often the wave occurs. Another term will be wavelength, which, if you wanted to remember, and we've talked about it before, is just the length of the wave. Remember, wavelength is the length of a wave, and it's the distance between two consecutive cycles. The top of this wave is called the crest, and the bottom is called a trough. The distance, if you wanted to remember what a wavelength is, remember it's the distance between the two crests or the two troughs. I tend to always remember the crests because it's easy to see. So I'll just do one crest to one crest, and that's my wavelength. And the speed by which it moves is called a v. Also velocity, because it will have a direction. Okay, so all waves, regardless of what they are, will have these common properties. Equilibrium point is the point that's in the middle. It's where the wave comes to rest, where nothing happens to it. The wavelength is just the length of the wave. So remember, the wavelength will be measured in meters. Amplitude is the height of the wave, also measured in meters. Crest is which point in the wave? Top. And trough is which point? The bottommost. Very good. Period is the time it takes to complete one cycle. A period is 1 over frequency. That is the definition of a period. Frequency is how often something happens, how often a wave happens. So this part of the wave versus this part of the wave. Which has a higher frequency? The left part or the right part? The right part. Good job. Who said that? Yay! The right part has more frequency than the left. It's because the right has more waves in a smaller time. And the last thing is going to be a new definition of angular frequency. It's called omega. And omega is defined as 2 pi f. Now, omega is kind of interesting because simple harmonic motion, do you remember simple harmonic motion was this motion? But omega is the corresponding circular motion. So every cycle can also be called simple harmonic if it goes around in a circle. For us in this class, just memorize the fact that omega is 2 pi f. So angular frequency is defined as 2 pi f. Omega is the Greek symbol. W, like with a fancy W. Yeah, so it's a Greek symbol for omega.